this video, we're going to talk about finding square roots and cube roots. We've talked about perfect squares, where you take a number and do 2 times 2 and get 4, or 2 squared. We've talked about cube roots, where you would do 2 times 2 times 2 and get 2 cubed and get 8. So today we're going to talk about doing the reverse, doing the inverse of these numbers. So we know that a perfect square has 2 identical factors. For example, 25 is the perfect square of 5. So 5 times 5, or 5 squared, equals 25. Also, negative 5 times negative 5, or negative 5 squared, equals 25. So positive 25 has 2 different ways that it can be a perfect square. So since 5 squared and negative 5 squared both equal 25, which we can write positive and negative 5, positive over negative 5, we can say that positive and negative 5 are the square root of 25. And the square root of 25 we write like this. It looks kind of like a division sign, but it has a check mark in front. And to make it, we do a check mark, and we go up, and then we write our other line, and we put our number underneath it. So this is how we would write the square root of 25. And we know that the answer is positive and negative 5, because both 5 times 5 equals the square root of 25, and negative 5 times negative 5 equals square root of 25. So let's try some examples. First one I asked you, the square root of 225. If you don't know all your perfect squares, you should soon, because I'm going to give you a quiz on them. What times itself equals 225? Well, I happen to know that 15 times 15 equals 225. Also, negative 15 times negative 15 equals 225. So we would say that the square root of 225 is equal to positive and negative 15. What else? This one's an easy one. The square root of 4. 2 squared equals 4. Negative 2 squared equals 4. So we would say that the square root of 4 is equal to positive and negative 2. Okay, what about this last one? Hopefully this is an easy one for you. What times itself equals 121? Well, 11 squared equals 121, which also means that negative 11 squared equals 121. So we would say that positive and negative 11 are the square roots of 121. So anytime we take a square root, you should get 2 answers, because both the positive and the negative are the square root. Why does this work? Remember those integer rules for multiplying and dividing, where when you multiply, if you have a positive times a positive, you get a positive answer. Or if you have a negative times a negative, you still get a positive answer. This all ties back to integer rules. So thanks to these integer rules, we have to put 2 answers when we take a square root. So let's talk about cube roots. Okay? So a perfect cube has 3 identical answers. So let's say we want to take the cube root of 8. Look at how this is written differently. We still have that square root symbol, but we write a 3 above it. You can take the cube root, you can take the 4th root, the 5th root, the 6th root. Tonight we're only dealing with square roots and cube roots. So we're taking the cube root of 8. 3 identical answers. 2 times 2 times 2. Or we can take the cube root of negative 8. Negative 2 times negative 2 times negative 2. Both of these have 3 identical answers, but they're different. So the cube root of 8 is positive 2, and the cube root of negative 8 is negative 2. This time we cannot write positive or negative 2. This is again due to integer rules. Why? Because this time we have 3 numbers. So if I multiply positive times a positive times a positive, that's okay, because my answer is going to be positive. But what happens with the negative? If I do a negative times a negative, we know that gives us a positive answer. Equals a positive. But when I multiply it by another negative, I'm getting a negative answer. So when I multiply here, I get 2 times 2, that gives me positive 4. When I multiply it by this other 2, I get my negative 8. Which is why the cube root of negative 8 is negative 2 times negative 2 times negative 2. But that's also why the cube root of positive 8 cannot be positive or negative 2. Hopefully that made sense. So let's come down here and do a couple of examples of cube roots. Remember, you want 3 identical answers, but you don't need to write the positive and negative in front. So let's look for the cube root of 27. So what number times itself 3 times equals 27? Cube roots are a little bit harder than square roots. So I have to think, what times what times what equals 27? So you've got to think back to your factor trees. So if I have 27 and I want to break it down, what times 3 equals 27? Well, I know that 3 times 9. So look, I have 3 3s. So 3 cubed is 27. So the cube root of 27 is 3. Just positive 3. What about negative 125? Well, since there's this negative, I know my answer is going to be negative. So I know I'm going to need a negative something. Well, what times what times what? So when I go in here, 125, if I break it down, I've got to think factors again. This is 3 times 25. No, it's not. Excuse me. 5 times 25. Whoop. I've got my 3 5s right there. Negative 5, because if I do negative 5 times negative 5 times negative 5, negative 5 times negative 5, that gives me positive 25 times negative 5, that gives me negative 125. Now, you have some other problems to work on. Please finish those for class tomorrow.